Solving by elimination. Can someone remind me the first method of solving simultaneous that I showed you? No, that was the second.
Oh, oops.
Go look in your notes. What was the first method that I gave you of solving simultaneously? It was a long laborious. Graphing it. So you draw the two lines, see where they cross over. That took a long time. The last lesson that I taught you, I showed you by substitution. The last and the one that you want to actually get good at and fast at is solving by elimination. It's called this because you eliminate one of the variables x or y. So you do this when both equations are in general form. If you remember back to solving by substitution, you used it when one of your equations was written with x or y as the subject. Here, both equations will be in this form. Ax plus by equals c. If both of your equations like this, you automatically go to solve by elimination. Steps for solving by elimination. Ensure both equations are in general form. Choose one of the variables to look at, x or y, in both equations. Step 2, I'm giving you a choice. But if you do your practice, you should get better at choosing which will be the easier option. Right now, you've got a choice. Step 3, look at the coefficient. Can someone remind me what the coefficient was? If I've got, yeah?
Number on the variable.
Yeah. So A would be the coefficient of x in ax plus by is equal to c. Look at the coefficient of the variable you chose, and you're just looking at it. You're just looking at that number. And then 4 is the hardest step. You need to decide on an operation that you apply to all the terms of one or both equations that will make the coefficient you're looking at equal in size and opposite in sign. Right now, that's a whole bunch of words. They're true, but they won't make sense to you until we do an example. So don't worry about it until after. Step 5, add the equations vertically to eliminate the chosen variable. Do you guys remember doing this in primary school? So 2, 3, 6 plus 19. Have you added like that before? 6 plus 9, 15, carry the 1, 3 plus 1, 4, 5, and then 2 down. You can do that with algebra as well. That's adding vertically, okay? Lastly, not second to last, 6, solve for the remaining variable. And then once you've got that, you substitute the variable you found in step 6 into either of the original equations and find the remaining variable you need. For the people that came in later, you just have to watch the video after. These people were here in time. Let's practice solving this by elimination. Are they both in general form?
Yes.
Step 1, out of the way. Step 2, choose one of the variables to look at, x or y in both equations. I'm going to pretend to be smooth-brained. Okay, I'm going to look at x because it comes first. I'm just looking at x right now. Look at the coefficient of that chosen variable in both equations. So what's the coefficient of x in the top equation?
5.
What's the coefficient in the bottom one?
3.
Good.
3.
So this is where the thinking comes in. Decide on an operation to apply to all of these terms in one or both that'll make the coefficients equal in size and opposite in sign. Are 5 and 3 equal in size?
No.
Are 5 and 3 opposite in sign?
No.
No, they're both positive. So, what's the smallest number that 5 and 3 go into nicely?
15.
15. So, what would I apply to the top variable, the top equation, if I wanted this to be 15?
Times it by 3.
Times the top one by 3. What would I have to times the bottom one by to make it 15 as well, but negative? Opposite sign, yes?
-5.
Good. Times by -5. So I'll do that. 15x takes 6y equals 7 times 3, 21. And then do the bottom one. So have we applied an operation to both of these things? Yeah? That's where the apply to one or both equations. Okay? 3x, -15x, take, what's -5 times by 2y, -10y. It's 5 times by 17, yeah, 50. I think that's -85. Do I trust myself? Let's see. 17 times 5. Yep, negative 85. Are the coefficients of x the same size but opposite sign now? Yep, so I can add vertically. So I put a line there, add. If I go 15x plus negative 15x, what do I have? No? Someone said negative x. What? If I've got 15 things and take 15 things, how many things do I have?
Yeah.
You didn't say it. How many? 0? Are we cool?
Mine's not processing.
Okay, 0. 0x. Thank you. And then negative 6. Negative 6y's take... I'm ignoring the plus because if you go negative 6y plus negative 10, what do a plus and minus become when you're working out? Negative. Good. So you go negative 6y, take 10y. It's going to be negative 16y equals 21 take 85, negative 64. What happened to the x? Did it disappear? Did it get eliminated? Did I eliminate x? Do I have any x's left here?
No.
Good. So now I've only got y's. That's why it's called solving by elimination. So what is the negative 16 doing to y? Good. What's the opposite of timesing by negative 16? Divide by negative 16. Divide this by negative 16. 64 divided by negative 16. That's going to tell you that y is equal to 4. Is that my answer? Am I done yet?
No.
I need to work out what x is. So, can I quickly just check? Did that demonstrate how step 4 works? Decide on an operation to apply all terms of one or both equations to make the coefficients. We looked at x. We did a smooth brain style because this is more work than you actually need to do. Okay? We worked out what y is. Now we're going to go substitute the variable you found in step 6 into either of the original equations. So I'm going to substitute y is equal to 4 into the top one here. So 5x take 2 lots of 4 equals 7. 5x take 8 equals 7. What's the opposite of taking 8 from something? Adding 8. So 5x is going to be 7, but 15. How do I get rid of the multiply by 5? Divide by 5. So x is going to be 3. That's the answer. Okay? Can anyone see a less smooth brain way of answering this? Because right now I gave you an option. You can look at x or y. Could you just eliminate y? If you look at the coefficients of y, are they the same size?
Yes.
Are they opposite sign?
Yes.
Don't waste all that time. So think about it instead of just doing the option, okay? The option's there. Hopefully if we do this, we get the same answer. So quickly, you notice that 2 and negative 2 are the same size, opposite sign. Just eliminate straight away. 5x plus 3x is 8x. Negative 2 plus 2, 0y. 7 plus 17, I think that's 24. What's the 8 doing to x? Timesing. What's the opposite of timesing by 8? Divide. X is going to be 24 divided by 8, which is 3. Is that the same as what we got before?
Yes.
And then can I substitute that 3 into either of these equations? It really doesn't matter which you choose. I'm going to substitute it into there. So 5 lots of 3, take 2y is equal to 7. 15 take 2y is equal to 7. What's the opposite of adding 15? Positive 15? Take 15. So that's going to be negative 2y is equal to negative 8. And then divide both sides by negative 2. Y is going to be 4. Is that the same as last time as well? So what I'd encourage you to do, these are the steps, but think about it so you do less work. I'll give you some writing time to get that example done.
So,
Yes?
if you substituted the 3 to the bottom equation, you still get the same answer.
Which one? Into the bottom one?
Yeah.
Okay. 3 times by 3 is 9. 9 plus 2y is equal to 17. That's in your head. What's the opposite of positive 9? take 9, so 17 take 9, that would be 8. And then what's 8 divided by 2? Y is equal to 4. Was that the same as what we got? It really doesn't matter which you choose, the substitution. My suggestion to you, choose the easier looking one. So why did I keep hammering the top one? Because this number is small. But it doesn't matter whichever clicks with your brain. Yeah?
Yeah.
Give me a minute and then I'll do this second one quickly. In that second one, I'll try to demonstrate how you should think about which coefficient to look at. Now let's look at example 2. Let's try those steps, but think about it first. Are they both in general form? Yep. Look at one of the coefficients. Now think about it. Are any of them the same size and opposite sign? No, so I'm going to have to multiply both. If I multiplied 4 and 3, I'm going to need 12 here. If I multiplied 3 and 2, what's the number going to be? 6. Do I want to deal with smaller numbers? So let's look at x instead. So I don't have to do all this work that I don't need to do. I need them the same size, but opposite sign. So what would I have to do to the top one to make it the same size, opposite sign as the bottom? Good. Times the top one by 2. What would I need to times the bottom one by to get it? -6 instead. What kind of a 3? Because right now it's positive. I need it to be -3. Okay, so write the resulting equation there is going to be 6x plus 8y equals 4. And the bottom one, -6x. What's a negative times by a negative going to be? Positive answer. So -3 times by -3 is positive 9y equals 7 times -3, -21. I have same size, opposite sign, so I can add vertically. There's going to be no x's left. What's 8y plus 9y? 17y. 4 take 21, that's -17. Opposite of timesing by 17 is dividing by 17. Y is going to be -1. I have half of my answer. Which of the formula would you like to substitute y is equal to -1 into? It really doesn't matter. Top one, because it's smaller numbers. So 3x plus 4 times by -1 equals 2. 3x, 4 times -1 is -4 equals 2. Opposite of taking 4? Huh?
Plus 4.
Plus 4, 3x is equal to 6. Opposite of timesing by 3?
Right.
Dividing 6 divided by 3 is 2. Writing time, and then I'll shut my mouth for... I'll say 30 minutes.